So we will discuss magnetic properties of materials. So the magnetic properties of the materials means on the basis of their magnetization properties, magnetic materials are classified into three types. Yeah, first one diamagnetic, second one paramagnetic, third one ferromagnetic. Substances. The chi value for diamagnetic is less than 0. Paramagnetic is greater than 0 but small scale. This is ferromagnetic, chi value is greater than 0 or greater than 1, large. So what are the examples? How to create the diamagnetic substances? What are the examples? We are going to discuss one by one and their uses also. First one is diamagnetic substances. The magnetic behavior of these diamagnetic substances is called diamagnetism. What is the meaning of diamagnetism? There are some magnetic materials which are called as diamagnetic substances. They have the tendency to travel from strong magnetic fields to the weak magnetic fields. That means, first of all, they won't respond for the applied magnetic fields. They have the tendency to travel from higher magnetic fields to low magnetic fields or weak magnetic fields. Higher magnetic fields to weaker magnetic fields or weak magnetic fields. So this is the first important point to observe the diamagnetic behavior of the substances. That means if this is the diamagnetic substance, the magnetic field lines always expels out like this. Expels out. There is no possibility to stay or to withstand a magnetic field inside the diamagnetic substance. The one more nature of this diamagnetic substance is diamagnetic substances are repelled by the magnets and magnet also repelled by the diamagnetic substances. That means magnet and diamagnetic substance both will repel each other. Magnet, diamagnetic substance. Both will repel each other. So like this, if this is the magnet, if this is the diamagnetic, they both will repel each other. So consequently, a large separation between the diamagnetic and magnetic materials. So the diamagnetic behavior is due to the alignment of the magnetic domains. Yeah. The alignment of the magnetic domains means in atomic structure we know that the electrons which are revolving around in the orbitals, they have the orbital momentum and magnetic momentum also. The revolving electrons has the orbital momentum. And magnetic momentum also. Suppose if these electrons which are placed in the domains, when they expose to the magnetic fields, if these domains are placed in the diamagnetic behavior, diamagnetic substances, the electrons which are moving in the same direction and the electrons moving in the opposite direction, these two types of electrons will be there in case of the atomic structure for any material, or it is metal or non-metal. So when you or when this diamagnetic substance is exposed to a magnetic field, the motion of the electrons which are in the same direction will be slowed down because of the applied magnetic field, and the motion of the electrons which are moving in the opposite direction speeds up, slows down, speeds up. So what we can understand this slowdown and speeds up because of the Lenz's law also. So in Lenz's law, when we applied a magnetic field near to the current carrying conductor or a simply insulated conductor, then the motion of the electrons which are at the rest are fasted up, the motion of the protons or the positive charge carriers are slows down. That's why there is a possibility for the net change in the magnetic flux and net change in the electric field also. Such like that, so the electrons which are moving in the same direction slows down, opposite direction speeds up. Because of that, the net magnetic momentum will be 0. That's why these diamagnetic behaviors are expelled out of the magnetic field. They won't be attracted by the applied magnetic fields. The examples of the diamagnetic substances are first one bismuth, second one copper, third one water, fourth one nitrogen at STP, fifth one sodium chloride. These are all the examples of diamagnetic substances. The diamagnets are useful as superconductors also. So the best use of the diamagnetic properties of diamagnetic substances is superconductors. So superconductors are some metals. When they are cooled at extremely low temperature, cooled to low temperature, at those low temperatures it will act as a best conductor and best magnetic substances. These superconductors will repel by the magnet and magnets repel the superconductors. So as we discussed, the chi value is -1. Therefore, B is equal to -H. Next one is paramagnetism. So paramagnetic substances are exactly ulta to the diamagnetic behavior. In diamagnetism, the magnets which are diamagnet, they are repelled by the magnetic fields and travels from higher fields to the lower fields. But paramagnetic substances travel or tendency to move from weak fields to strong fields. This is the paramagnetic behavior. So this is paramagnetic material. Why it is happening actually? So as usually we know that there is a magnetic domain which contains the electrons. So there is a randomness.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.